Welcome to Physical Science. This is Mrs. Tratner. This lesson is on electromagnetic waves. These are the objectives for the unit. These are our goals for today. Identify the types of electromagnetic waves. Understand that each type of wave has its own wavelength. Understand how these particles transfer energy. Okay, so this lesson is focusing on electromagnetic waves. The electromagnetic waves travel without a medium, and they are transverse waves, so they go up and down. They transfer electrical and magnetic fields. They travel through space, they don't need a medium, and they travel at the speed of light. Electromagnetic waves are composed of an entire spectrum of waves. They all travel at the same speed, but at different frequencies. There's light, and those are the only electromagnetic waves that are visible. All the other waves are invisible. So all of the different waves that are part of the electromagnetic spectrum include radio waves, microwaves, infrared waves, ultraviolet rays, X-rays, and gamma rays. Radio waves are have the longest wavelength and the lowest frequency, and radios can detect these types of radio waves. Remember that we can calculate the speed of a wave by taking its wavelength and multiplying it by the frequency. Those waves that have the longest wavelength have the lowest frequency, and those waves that have the shortest wavelength have the highest frequency. So the electromagnetic spectrum, like I said, are made up of all of these different waves, and on the left with the radio waves, they are the longest wavelength and the lowest frequency, and then microwaves, then infrared rays, then visible light. And visible light is divided into the different colors: red, orange, yellow, green, blue, and violet. Then we have ultraviolet rays, X-rays, and gamma rays. Gamma rays have the shortest wavelength and the highest frequency. So when we talk about radio waves that have the longest wavelength and the lowest frequency, they include those waves that are broadcasted, okay, from one tower, and then your radio can pick it up. Microwaves also are able to be broadcast. So when we talk about radio waves, they carry a signal for both radio and television. The broadcast station sends out radio waves at a certain frequency. Then your radio or TV antenna picks up the waves and converts that signal into an electrical signal. And then inside of your radio or your TV, okay, the radio takes that electrical signal and converts it to sound. In your TV, the signal is converted from sound to sound and pictures. Microwaves, you normally think of your microwave oven that can cook and reheat your food. But microwaves have other uses as well, including cellular phone communication and radar. Radar stands for radio detection and ranging. It's a system that reflects radio waves to detect objects and measure their distance and speed. So that's how a radar works. So the radar device can use the Doppler effect in order to measure the speed. So if we were to think about like a radar detector that a police officer might use, the way that that would work is that um, it will send out a radio wave, and then that radio wave reflects off of the car. And because the car is in motion, the frequency of the reflected wave is different than the frequency of the original wave, and the difference between those frequencies calculates the car's speed, which is kind of cool. Then we have infrared rays, and they are invisible again. And the way that they can use infrared waves or rays is to see like inside of a house if there are warm spots or cold spots. Infrared rays have a higher frequency than radio waves, so they have more energy. And we can feel that energy in the form of heat. We often call them heat rays, like in a heat lamp. A heat lamp will have a bulb that will give off mostly infrared rays and very little visible light. It's kind of like those lamps that you see at a restaurant that keep food warm. They can also use infrared rays in these infrared cameras. And warmer objects give off more energy at higher frequencies, so they can tell the difference in heat, like within a house, based on the amount of energy that's being given off. Then we have visible light, and we'll talk a little bit more about that. Ultraviolet rays have higher frequencies than visible light, so they carry more energy. We know that ultraviolet can cause damage to living cells, and ultraviolet lamps are often used to kill bacteria on hospital equipment. Very small doses of ultraviolet are useful because we can use that to kill skin cells and that might be damaged. And they also help skin cells produce vitamin D. But too much exposure is dangerous. That's how we get sunburn. It can also cause skin cancer, and it can cause damage to your eyes. That's why you're always encouraged to put sunblock on and sunglasses to limit that damage. X-rays are electromagnetic waves that are just, the frequencies are higher than ultraviolet. And because of their high frequencies, again, they carry more energy, and they can penetrate most matter. That's why we use them to take X-rays, because they can penetrate. So when they use an X-ray, it can penetrate the skin, but it doesn't penetrate your bones. But what will happen is that your bone will absorb those X-rays and doesn't allow them to pass through. That's why you shouldn't be exposed to them for long periods of time. That's why you sometimes wear a lead vest when you get your teeth x-rayed, because they only want to look at your teeth and they don't want to expose the rest of your body to those x-rays. Too much exposure can cause cancer. So you have that. And then finally we have gamma rays. They're the shortest wavelength and the highest frequency, and they have the greatest amount of energy. They are the most penetrating of all of the electromagnetic waves. There are some radioactive substances and certain nuclear reactions that can produce gamma rays. But we can also use gamma rays for medical uses. Like we can use them to kill cancer cells inside the body. We can use them to view the body's internal structure. And the way that they do that is sometimes they'll put like a dye inside your body, and then what'll happen is that the dye will emit gamma rays, and then you have a gamma ray detector, and it'll help form those images inside the body. Some objects in space give off bursts of gamma rays, but most of the gamma rays are blocked by the Earth's atmosphere. So there are telescopes that can detect them, so that way they can, prepare if something were to happen. So all these different waves come from the sun. So all of the electromagnetic energy, all these electromagnetic waves can come from the sun. Now, when electromagnetic waves travel, remember they don't need a medium, and they're produced by charged particles. And every single little charged particle has an electrical field surrounding it. And as those charged particles move, they produce a magnetic field as well. And so what'll happen is that the charged particles will move up and down. And as they're moving up and down, they create a magnetic field around them that moves perpendicular to them. So that magnetic field moves back and forth. So if the charged particle moves up and down, the magnetic field will move left to right. If that charged particle changes direction, the magnetic field will also change direction. It will always run perpendicular to that electrical field, or at a 90-degree angle. So here again is another illustration of the electromagnetic spectrum. And you can see that radio waves have the longest wavelength and the lowest frequency. And gamma rays, which is at the very end, have the shortest wavelength and the highest frequency. So what we'll be doing in class is we'll be looking at a virtual lab with electromagnetic waves. And we'll be looking at answering the question, what is the electromagnetic spectrum? So we will be looking at the virtual lab in class, and then following the procedure and answering questions. If you do have questions about the electromagnetic spectrum, please make sure that you ask during our live class. And that'll do it.